Pantheon AI presents What is First Principle Thinking? Welcome back to the podcast. Today we're diving into a concept that sounds a bit academic, but it's actually one of the most powerful tools for problem solving and innovation. First Principles Thinking.
Oh, I've heard that term thrown around, especially in tech circles. Elon Musk talks about it a lot, right? What exactly is it?
Exactly. Think of it this way. Instead of looking at how everyone else solves a problem, you strip away everything. Every assumption, every convention, every best practice. You get rid of it all.
So you're left with
The absolute basic truths. The fundamental building blocks that trump must be true, based on physics, logic, math. You're asking, what is this problem really made of?
Okay, so it's like deconstructing something down to its atoms?
Pretty much. And then you rebuild your understanding, or even a new solution, from those core truths. It's the opposite of just asking, how do others usually do this?
Got it. And where did this idea even come from?
Well, the term first principles goes way back to Aristotle. He used archai for those self-evident truths that form the foundation of an argument.
Aristotle. Okay, so it's an old philosophical concept applied to modern problems.
Exactly. And in modern business and engineering, people like Elon Musk really popularized it. He used it to rethink things like battery cost for electric vehicles.
Right. I think that's the example I heard. Instead of just accepting the market price for a battery pack, which was like $600 per kilowatt hour back then.
Yeah, instead of that, he looked at the raw materials. Aluminum, nickel, lithium, polymers. What do they cost? And based on that, he calculated the theoretical floor was closer to $80 to $90 per kilowatt hour.
Wow, that's a massive difference. And that led to redesigning the whole pack and supply chain to get closer to that fundamental cost.
Precisely. And that highlights the key difference between first principles thinking and what's often called analogy-based reasoning.
Okay, tell me more about that difference.
Analogy-based thinking is basically starting with how others do it. You look at precedent. You benchmark against competitors. It's faster, lower cognitive load.
Okay, makes sense. It's like, how did company X solve this? Let's do something similar.
Right. But it usually only leads to incremental improvements. You're just tweaking the existing model.
And first principles?
That starts with what must be true. It relies on physics, math, logic. It's higher effort up front. Definitely. It's like digging down to bedrock.
Yeah, that sounds like more work.
It is, but the leverage is huge. It opens the door to non-obvious step-change solutions. Solutions that others miss because they're stuck in the analogy trap.
Okay, so it's for when you need a breakthrough, not just a small improvement.
Exactly, and there's actually a pretty neat 4-step playbook you can use. It makes it less abstract.
Ooh, a playbook. I like that. What's step one?
First, you define the exact outcome you want. Be super specific, not just make payments faster, but reduce transaction settlement time from T+2 to real time.
Got it. Clear goal.
Step 2. Break the problem down into its atomic parts. What are the fundamental pieces? For payments, maybe it's hardware latency, the consensus algorithm, regulatory checkpoints, fraud risk buffers.
Okay, listing all the components.
Right. Step 3 is crucial. Examine each part and tag it. Is it a hard constraint, like the speed of light for hardware latency? Or is it an assumption, or a convention, like that 2-day regulatory buffer that might not actually be law in all places?
Separating the must-be-trues from the we-just-do-it-this-ways.
Exactly. That's where you find the assumptions to challenge. And then step 4 is to reconstruct the solution space from the ground up, using only the hard constraints.
So, if the only hard limit for payments is that tiny bit of latency from physics, you realize real-time is actually possible?
Yeah, and you focus on building a solution based on that possibility, like cryptographic proofs and working with regulators on a sandbox, rather than just trying to speed up the old batch file process.
That makes so much sense. You're not trying to optimize the old way. You're building a completely new way based on what's fundamentally possible.
Precisely. We see this in other areas too, like space launch. The common wisdom was rockets are disposable. But first principles, the math around mass fractions, showed reusability was viable if the engines could handle a small penalty.
And look at SpaceX now. Reusable rockets are becoming the norm.
Or even something like KYC, Know Your Customer, in fintech. People thought manual ID checks were required. But the regulation often specifies the outcome verification, not the method. That opens the door to automating it with OCR and liveness tests, cutting costs dramatically.
Fascinating. It really is about questioning everything.
It is, and you can apply this day to day. A great tip is to literally write down every assumption in a problem. Tag them A1, A2, etc. Then test each one against physics, math, the actual rulebook.
Okay, make the assumptions visible.
Yes, and alternate your zoom level. Look at the micro details, component physics, but also the macro system constraints. Don't get lost in just one level.
Good point. You need both perspectives.
And try the what if it had to be 10x cheaper or faster trick. That really forces you past incremental thinking.
Oh, I like that. It breaks the mold immediately.
Totally. Now, it's not for everything. Don't use it for low-stakes decisions like which brand of office chair to buy. The effort outweighs the benefit there.
Right, analyze everything would be exhausting.
Exactly. Or if you're dealing with non-negotiable external rules, like a fixed tax rate, first principles will just confirm the constraint. It won't help you change it.
Okay, so save it for the big, hairy problems where innovation is key.
Precisely. It's mental excavation. You dig down to the bedrock truths, discard all the debris of habit and convention, and build back up. Often, you find that things you thought were impossible were just based on unexamined assumptions.
That's a powerful idea. So how do teams actually use this? Is there a more detailed process?
Yeah, there's a more advanced 7-stage workflow. It starts with framing that precise job to be done metric we talked about.
Like the real-time settlement example.
Yes. Then that exhaustive decomposition down to physical, informational, or legal primitives. Tagging constraints, stress testing assumptions. That's stages 1 through 3.
Okay, building on the 4-step playbook.
Right. Stage 4 is that ground-up reimagining, coming up with candidate mechanisms based only on the hard constraints. Then, crucially, stage 5 is rapid physical or digital experiments. Proofs of concept, time-boxed.
Test the new ideas quickly.
Exactly. Stage 6 is systems synthesis and adding time-only necessary guardrails. Compliance, UX, risk buffers. Don't pile the old assumptions back on.
Just what's essential.
Yeah, and finally, stage 7, postmortem and canonicalization. Documenting the new axioms and derivations, making it part of the team's knowledge base so others can build on it.
So it becomes the new first principles for the next problem.
Exactly. It's a continuous cycle of skepticism and rebuilding. You can even make it part of the culture. Things like having an assumption registry, where teams document their beliefs, or Apollo 13 feet sprints targeting 10x improvements, or even Red Team Fridays, where someone tries to attack sacred processes.
Red Team Fridays sounds intense.
It's about institutionalizing that continuous skepticism. And personally, you can build this skill. Just challenging 3 beliefs about your work each day, doing weekly estimation challenges.
Like the Fermi questions?
Yeah, estimating things from scratch. Or reading tutorials backwards to reconstruct the steps. It trains your brain to deconstruct.
That's a clever practice.
Ultimately, first principles thinking isn't just a brainstorming technique. It's really an operating system for innovation. Treat assumptions like code. Compile them against physics and law. Run experiments, and keep refactoring.
It sounds like it gives teams a real competitive edge, building moats that others can't just copy by benchmarking.
Absolutely. It's how you turn the impossible into baseline engineering. Definitely a powerful tool to add to your belt.
Great stuff. Thanks for breaking that down. Pantheon AI, your information co-pilot.
Because learning shouldn't feel like a full-time job. Take care and see you next time.